Hi, it's T. This is my first installment of predicting the future using R. I'm going to be making a playlist on how to essentially forecast using a time series, which is predicting the future. Now, before I go any further, I need to explain what time series is. A time series is just something being measured over a period of time. This example here is the number of COVID deaths from 2020 to 2023. So it's just a measurement over time. A less morbid example would be the number of people visiting Disneyland from 2020 to 2023. I imagine if I had that graph up here, it would be like inverted right here because the peak of the pandemic will probably less will result in less people moving. But yeah, so that's all a time series is. So, and then the aim of forecasting, the part of predicting the future, and most people have heard of forecasting the weather before. You can do that for other things as well. So, is predicting what's going to happen next. So, this can be very beneficial to different industries, and they can be applied to multiple components. So, it's a great skill to have. So, I'm going to break down how to carry out a time series model. First, there's three layers to a time series analysis. There's the components, which can then be broken down into four, which is trend, seasonality, cycle, and error, variation, and noise. There's a forecasting model, which is the ARIMA, auto-regressive, integrated, and the moving average. And then the implementation tool, which is R, already stated. So I'm going to go through these two in more detail as the introduction video. So the four components. So time series has four components associated to it, which is the trend, which is what is the data doing over a long period of time? Is it trending upwards, downwards? Is it just changing direction? That's the trend. So what this image here is the image of what you would see, with all the components being pointed out. So here's a time series. So the components aren't pointed out here, but this has the components there. So what I've done is I've broken it down into four, so you can see the components being explained have been decomposed. So here's a trend line, an upward trend, so you can easily see it, but it's also here. And then number two is a seasonal aspect, which is regular variations that happen less than a year. So it can't be longer than a year period. So you can see this uniform, regular variation, this seasonal aspect. Seasonal aspect can be, regular variation that happens hourly or happens daily. Or it could happen quarterly, like this example is showing. It has to be less than a year. And then cyclical is an oscillating variation, but it doesn't have to be less than a year, over a long period of time. So for example, a real world example would be the boom and bust of the economy. It's cyclical, it happens over a long period of time, and it doesn't necessarily have to be uniform, like seasonal. And then number four is irregular fluctuations, just random variation or noise within a process. And there's a way of dealing with this. So the second part is the model used. What we're going to use to predict the time series, like the COVID deaths, for example. So autoregressive, the model is called the ARIMA. It's a very famous model. The AR portion of it is autoregressive, which has to do with how influential past data is on future data. And then there's integrated, which has to do with the trend and seasonality. And then there's the moving average, which is associated to the error and variation. This portion will smooth out the error and variation portion of the time series. And then you implement the model using R, and you should be able to predict the future deaths. And then you will at the end of it get like a confidence interval, how confident you are that this prediction is accurate. Yeah, so like, subscribe, and stay tuned because I'm going to be going through the entire process. Thanks for watching.